Welcome back to Tales of Chemistry. Today, let us discuss what is molecular formula, what is the meaning of molecular formula of a compound, as well as how is molecular formula related to empirical formula. Afterwards, we will be doing some numericals. Now, molecular formula. See, now if you look at these examples which I have written, the first one, glucose, its molecular formula is C6H12O6. Now, the meaning of this word molecular formula is it gives us the exact number of atoms of all elements present in one molecule of the compound. Now, in glucose, C6H12O6 tells us that there are 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms in one molecule of glucose. Similarly, the next example, hydrogen peroxide. H2O2 is the formula. What does that mean? It means in one molecule of hydrogen peroxide, you have 2 atoms of hydrogen and 2 atoms of oxygen. Benzene, we are yet to learn what benzene is. You will come across this compound benzene in organic chemistry. Now, C6H6 tells us that in one molecule of benzene, you will find 6 atoms of carbon and 6 atoms of hydrogen. The last example that I have taken, calcium carbonate, CaCO3. So, this means in one molecule of calcium carbonate, you will find 1 atom of calcium, 1 atom of carbon, 3 atoms of oxygen. Therefore, molecular formula represents the exact number of atoms, actual number of atoms of each element present in one molecule of the compound. I hope this word molecular formula meaning is clear. Moving on to the next, empirical formula. Empirical formula of a compound is the simplest whole number ratio. So, actual ratio is molecular formula. Simplest whole number ratio will be called empirical formula. Now, let me write the molecular formula of glucose here. C6H12O6. This is the molecular formula. What is the ratio between the atoms of carbon, hydrogen, and oxygen? 6:12:6. Now, when you look at the ratio 6:12:6, you can clearly make out that all these numbers are divisible by 6. So, when you divide all the numbers by 6, you get the ratio 1:2:1, which is the simplest possible whole number ratio. Therefore, empirical formula of glucose is CH2O. C6H12O6 has now become CH2O. That means C1H2O1. I have not written the 1 initially, that is it. So, empirical formula is CH2O. Let's take the next example, hydrogen peroxide. On the left side, I'm writing the molecular formula. Now, mentally, you can solve this. Ratio is 2:2. When you simplify, the ratio becomes 1:1. So, HO will be the empirical formula. Moving on, the next one, benzene. Molecular formula C6H6. Ratio 6:6. when you convert it to the simplest whole number ratio, yeah, both the digits, both the numbers are divisible by 6. So you get the ratio 1:1. Therefore, C1H1 or CH is the empirical formula of benzene. Last example taken was calcium carbonate, and in calcium carbonate, already the ratio is 1:1:3. Already it is 1:1:3. You cannot further subdivide this. You cannot divide this anymore into a simple ratio. Already calcium is 1. Carbon is a 1. So lesser than 1 is not possible. So here calcium carbonate's molecular formula and empirical formula are one and the same. Further simplification of this 1:1:3 was not possible. Okay, now both the definitions you need to study. What is empirical formula? What is molecular formula? Now, let us look at this question and learn how to solve a numerical. Determine the empirical formula of a compound of sodium, sulfur, and oxygen. So, first of all, we need to draw a table. Okay, so in that, the first column is for element. What are the elements present? I have sodium, then I have sulfur, and I also have oxygen. Second column is for percentage. Whatever percentage is given, we are just copying it. 29.11%, 40.51 sulfur, and oxygen is 30.38%. And the next column, the atomic weight. Here I have not written the atomic weight, but in the examination, atomic weight will be given to you. Atomic weight of sodium is 23. Sulfur is 32 and oxygen is 16. The next column is relative number. Relative number is calculated by dividing percentage by atomic weight. Whatever percentage is given, divide it with atomic weight. So, for sodium, it is 29.11 by 23. So approximately 1 point something we should get on solving. This is 1.266. 1.266. You can solve up to the second decimal place. That is enough. Now, second one, relative number for sulfur. 40.51 divided by 32. This will also be, 1 point something. On solving, this again comes as 1.266. Now, the next one, 30.38 by 16. This is, 1 point. If it was 32, we could have written 2 point something, but this is 1.898. You can use the long division method to solve. You're not allowed to use a calculator. So solve by the long division method itself. Once you get the relative number, the next column is for simple ratio. Simple ratio is calculated by dividing all the numbers. I have 1.266, again 1.266, then 1.898. Divide all the numbers by the lowest number. Lowest number here is 1.266. Divide the first number by the lowest number. Divide the second number by the lowest number. Divide the third number by the lowest number. And this will be 1, this is a 1, but this is 1.5. Now, if it was something closer to 1.1, 1.2, okay, then I would have rounded it off to 1. And if it was something like 1.8 or 1.9, etc., then again we can round it off to 2. But here, what I have got is exact 1.5. When I get exact 1.5, I cannot round this off. Instead, this has to be multiplied with 2. When I multiply the last number with 2, definitely it becomes compulsory to multiply the other numbers also with 2. So now my simplest ratio is 2, 2 and 3. The simplest ratio now is 2 is to 2 is to 3. Therefore, the empirical formula is Na 2 times, okay, number corresponding to Na is 2. Sulfur S2, the number corresponding to sulfur is 2. And oxygen 3. Okay, so Na2, S2, O3 is the empirical formula of the, the compound which is given in the question. Okay, luckily the question was just to calculate empirical formula and we are done with it. Let's solve the next one. Determine the molecular formula of a compound having the following percentage composition. So, first column, which is for element. I'll just write E here. This is for element, and the elements are carbon, hydrogen, and oxygen. Second column is for percentage. Percentage given is 26.59, 2.22, 71.19. Next is for atomic weight. I've told you already, atomic weight will be given to you in the question paper. C is 12, this is 1, this is 16. Next column is for relative number. And then the last column, simple ratio. Relative number is calculated by dividing the percentage by atomic number. So let's do it everywhere in all the cases. 2.22 by 1, 71.19 by 16. Now, 26.59 by 1. Okay, so this answer here is, let's divide this. 26.59 by 12. This is 2.215, and the second one is 2.22, and the third one 71.19 divided by 16 is equal to 4.44. The first one I can round it off as 2.22 now. So lowest number is 2.22. Divide all the numbers by the least number, the lowest number. That is how we calculate the simple ratio. See, I'm done with it. And here you get 1, 1, and then 2, right? So the ratio here is 1 is to 1 is to 2. Therefore, the empirical formula will be CHO2. Empirical formula in this case is CHO2. Okay, now the question continues. Question is not just to find out empirical formula, but to find out molecular formula. Okay, so how do we calculate the molecular formula? Well, so first of all, let me write the additional data which is given, vapor density. So, vapor density of this compound is 45. When vapor density is 45, we must know that molecular weight, okay, of any compound is twice the vapor density. So it is 2 into 45. Okay, so molecular weight is now 90. Then to find out the molecular formula, we also need the empirical formula weight. Empirical formula weight, which is equal to a weight of CHO2. How do I calculate? Carbon's atomic weight is 12. Hydrogen's atomic weight is 1. Oxygen's atomic weight is 16. But you have 2 atoms of oxygen. So add them now. 12 plus 1, 13. 13 plus 16 into 2, that is 32. Okay, so that gives you 45. Empirical formula weight now is 45. Then empirical formula n times is molecular formula. Okay, how do I know this? From the definition, molecular formula is the exact number of atoms of all elements. Empirical formula is the simplest whole number ratio. So, empirical formula multiplied by a particular number is equal to the molecular formula. Now, our task is to find out what is N. N is calculated by dividing molecular weight by empirical formula weight. Molecular weight you have already calculated. It is 90 divided by empirical formula weight, which is 45. That is 2, which means empirical formula repeated twice is the molecular formula. What is your empirical formula here in this question? Let us scroll up. Empirical formula was CHO2. Now, that CHO2 repeated twice, that is C2H2O4. This is the molecular formula of the compound. I hope you have understood this. C2H2O4 is the molecular formula. Yeah. Now, move to the next question. Compound of carbon and hydrogen is found to have contain 40% of compound of carbon, hydrogen and oxygen, has 40% of carbon, 6.7% of oxygen and 6.7% of hydrogen, my bad, and 53.3% of oxygen. So you need to calculate empirical formula as well as molecular formula. First column is for element. The elements are carbon, hydrogen, and oxygen. Percentage is given to us. Carbon is 40%, hydrogen is 6.7%, and oxygen is 53.3%. Atomic weight 12, 1, 16. Relative number 40 by 12. Now you don't need any explanation. 6.7 by 1, 53.3 by 16. So this 40 by 12 gives us 3.33. This will be 6.7. This is again 3.33. Now, simple ratio. Simple ratio, pick the least number, 3.33, divide all the numbers by 3.33. So this is the first one, which gives you result 1, 6.7 by 3.33, which is also equal to 1. Then 3.33 by 3.33, that is again, sorry, this is 2, this is a 1. Okay, so now the empirical formula is CH2O. Empirical formula weight, side by side, let us calculate. Empirical formula weight, that is 12 plus 2 into 1 plus 16. So 12 plus 2, 14. 14 plus 16, that is equal to 30. Empirical formula weight. Vapor density is given to us in the question. Vapor density is 30. Now, when vapor density is 30, twice vapor density, 2 into vapor density is molecular weight. And molecular weight is equal to 2 into 30, 60. N, what was the formula to calculate N? N is equal to a molecular weight divided by empirical formula weight. Empirical formula weight. So that is 60 divided by 30. Here also the value of N is equal to 2. Now don't think that N should always be equal to 2. No, N can be any number, any whole number. So here N is equal to 2. Now empirical formula 2 times will be molecular formula. So molecular formula is equal to CH2O. That is the empirical formula, which is repeated 2 times. So what is CH2O 2 times? This will be C2H4O2. C2H4O2 is the empirical formula. So have a look at the entire solution once again. We calculated empirical formula. We used vapor density to calculate the molecular weight. We calculated empirical formula weight. Empirical formula weight is used to calculate N value, that is molecular weight, by empirical formula weight. And then using N, or using the relation, empirical formula N times gives you molecular formula. The molecular formula is also calculated. Now let's quickly look at question number 4. This is a slightly different question. A chemical reaction showed that 10.47 gram of the compound contained 6.21 gram of metal X and the rest of a non-metal Y. So the elements present are X and Y. But percentage is not given. Instead, total weight and weight of metal is given. Okay, so here, let us write the total weight of the compound is 10.47 gram and a weight of metal X is equal to 6.21 gram. So, percentage of X will be, percentage of metal X will be a weight of X in the compound, in the given compound, divided by total weight of the compound into 100. So this is equal to 6.21 by 10.47 into 100, which on solving gives us 59.31%. Now, the advantage of this particular question is you just have elements X and Y. Okay, you just have elements X and Y. Therefore, weight a percentage of a Y can be calculated as 100 minus 59.31. Otherwise, what you could do is find out the weight of a Y, that is 10.47 minus 6.21. That will give you weight of a Y, and use the weight of a Y to calculate its percentage. But here it was easy. 100 minus 59.31, which will be equal to 40.69%. Now, once you get the percent, it is again easy to calculate the empirical formula. Elements are called X and Y. The percentage is given, we calculated actually 59.31 and 40.69. Atomic weight, this is 207 and this was 35.5. Relative number, 59.31 divided by 207, 40.69 divided by 35.5. On solving, the first one is 0.286 and the second one is 1.146. Then the simple ratio. Pick the lowest number, which is 286. Divide both the numbers by the lowest number. That is equal to 1 in the case of X, and in the case of Y, 1.146 by 0.286. This is equal to 4. So, the empirical formula here is X1 and Y4, which can be written as XY4. XY4 is the empirical formula. So this was a different question. Here, the percentage was not given directly. Instead, the weights were given. So using the weight, we can calculate percentage, and from the percentage, we can calculate the empirical formula. Now, look at the fifth question. Again, this question is totally different. They have given the percentage, but calculate the molecular formula, assuming that all hydrogen in the compound is in combination with oxygen as water of crystallization. Molecular weight is given to help us calculate the molecular formula. So let's first find out the empirical formula. Elements are sodium, sulfur, hydrogen, and oxygen. Percentages 18.6, 25.8, 4.03, 51.58. Atomic weight, sodium 23, 32, 1, 16 respectively for all the other elements. Relative number, 18.6 by 23, which is equal to 0.8. Second one, 25.8 by 32, which is equal to again 0.8. 4.03 by 1, that is 4.03 itself. Sorry. Now, last one, 51.58 by 16 is equal to 3.22. Pick the lowest number, 0.8. Divide all the numbers by the lowest number. So the first one is 1. Second one also is equal to 1. Third one is 4.03 by 0.8, that is equal to 5. And the last one, 3.22 by 0.8, which is equal to 4. Now, the empirical formula of this compound is NaSH5O4. Use the empirical formula, okay, to calculate molecular formula. So first one is empirical formula of weight. Okay. Empirical formula of weight. That is equal to sulfur is 23. Sodium is 23. This is 32, sulfur. Hydrogen is 1. I have 5 hydrogen, so 5 into 1, which is 5, plus 4 atoms of oxygen. Each atom of oxygen is 16. 16 into 4, that is 64. Okay, now adding them together, the empirical formula weight comes around 124. Next, molecular weight is given to us, which is 248. N is to be calculated. N is molecular weight divided by empirical formula weight, which is 248 by 124. That is equal to 2. And then finally, what we know is empirical formula repeated n times. That is, here empirical formula repeated 2 times is the molecular formula. Therefore, molecular formula is empirical formula, which is NaSH5O4 repeated 2 times. That is Na2S2H10O8. But the question was telling us that all the hydrogen present is in the form of water of crystallization. So I must rewrite the molecular formula. Na2S2. This I'm writing completely because sodium and sulfur are not involved in water of crystallization. Now, 10 hydrogens are there. All that 10 hydrogen exist as water. So, how many water molecules should be there? 5, right? 5 twos are 10. 10 hydrogens are present, and entire hydrogen is existing as water molecule. Now, in 5 water molecules totally, how many atoms of oxygen have I used? I have used 5 atoms of oxygen, but I have 8 atoms of oxygen. So the remaining 3 will be appearing here. Therefore, the molecular formula is Na2S2O3 dot 5H2O. That 5H2O represents that 5 molecules of water of crystallization. Next question. This is a very simple question. Empirical formula of a compound is given. So copy the data which is given to you. EF is XY2. Empirical formula weight is equal to vapor density. Empirical formula weight is equal to vapor density. Okay, so use this to find out N. N will be molecular weight by empirical formula weight. Molecular weight is what? Twice into 2 into vapor density, twice vapor density. And this is empirical formula weight. Now I will rewrite this 2 vapor density, twice vapor density by empirical formula weight. In the question, it is given that empirical formula weight is nothing but vapor density. So here in the denominator, instead of empirical formula weight, now I will write vapor density. Now cancel that vapor density. So you get your N value as 2. So empirical formula twice is your molecular formula. Therefore, molecular formula will be XY2 2 times. That is X2Y4. So that was the question. 7th one. This is again even simple. State the empirical formula of each compound whose molecular formula is C5H10. So first one, molecular formula is C5H10. Copy the ratio, 5:10. What is common? Can we divide both by 5? Yes. So if you divide both by 5, your ratio becomes 1:2. So the empirical formula here is CH2. Done. Next one. H2CO2. H2CO2. Now, what is the ratio? This is molecular formula. Ratio is 2:1:2. Already there is a 1 which clearly tells me that I cannot make it undergo any further simplification. It's already in the simplest possible ratio. So empirical formula and molecular formula are the same, H2CO2. Okay, now the last question for today. Calculate the empirical formula of a compound whose molecular formula is, molecular formula is C8H6O4. They have given the empirical formula weight. Actually, I don't need the empirical formula weight. I will just copy the ratio, this, and can I divide all of them by 4? No, 6 is not divisible by 4. So can I divide all the numbers by 2? Very much yes. So when I divide all the numbers by 2, I get 4:3:2. Therefore, the empirical formula is C4H3O2. Now, since they have given empirical formula weight, how do we include that? I mean, another solution, including the empirical formula weight. Now, empirical formula weight is 83. calculate molecular formula weight C8, that is 12 into 8, 6 into 1, and 16 into 4. So on solving this, you get 96 plus 6 plus 64, which is 166. N can be calculated by dividing molecular weight by empirical formula weight. So that gives you 2. Okay, so you get n value 2, which means divide all the digits, all the numbers in the molecular formula by 2, which is again giving us the same answer. Empirical formula is C4H3O2. The first method was the easiest. Now, since in the question empirical formula weight is given, I have explained here how to use that data also and solve your question. That's all for in this video. Stay tuned for more videos. Thank you.